morning, grade 12s, and welcome to geometric sequences. I'm unsure as to why this topic is only introduced in grade 12. It's perhaps got something to do with the fact that it may require some advanced exponential equations at some stage, but it's actually really straightforward. It's another one of those situations where you really need to know the formula and you need to be able to plug in the right values in the correct places and you'll be a-okay. So I'm going to dive straight into something as simple as 3, 6, 12, 24. Now, before we consider what's going on here, let's quickly recap the two kinds of sequences we've covered already. The first one is the linear sequence, or the arithmetic sequence, same thing, where one term is a term is generated by adding or subtracting something from the previous term, right? There's always a constant difference between the terms, right? Then you get a quadratic sequence, which is basically a parabola, whereby you are eventually you're squaring a specific value, and the way to find the general formula of a quadratic sequence is to determine that second difference, which will always be constant. Okay, so this geometric sequence is nothing like a quadratic nor linear. In other words, we are not looking for a second or first constant difference. We are looking at something called a ratio. Now, it's a-okay if you are given a sequence and you treat it like an arithmetic, or you explore the differences to see if the sequence is perhaps arithmetic or quadratic. In other words, you can say, what did I add to 3 to get 6? Plus 3. 6 to 12 plus 6. 12 to 24 plus 12. When you start seeing that same pattern repeat itself in the differences, then you know you're dealing with a geometric sequence. But don't even worry, there's an easier way as well. So basically what I'm trying to say is, if you're looking for the constant difference, you won't find a first constant difference in a geometric sequence, and you won't find a second constant difference in a geometric sequence. So what should our next strategy be? Let's think about basic maths back to grade 1. After adding and subtracting, the next step into the world of mathematics was multiplying. Yes, you guessed it. And what goes hand in hand with multiplying? Division, of course. So let's see. To get from 3 to 6, did we not perhaps multiply by something? Likewise, from 6 to 12, did we multiply by something? And 12 to 24, what could that number be? If we don't know, you can name these terms in the sequence, term 1, 2, 3, and 4. And let's check on our calculator. What would the second term divided by the first term give us if we didn't know what we were multiplying by? We would go 6 divided by 3, and you would see, yes, we get 2. Then, what would term 3 divided by term 2 give us? Let's have a look. 12 divided by 6, yes, we get 2 again. So, I know you saw this from the very get-go, we are multiplying by a factor of 2 every single time. And that number, that special number that we multiply by each time, is what we call a constant ratio. So there won't be a constant difference, but there will be a constant ratio. Why the word ratio? Because in order to get the number by which you are multiplying each term in order to get the next term, we divide a big term with the term just before it. We divide term 3 with term 2, and we double check ourselves. Is term 2 divided by term 1 the same answer? Yes, it is. Great stuff. We have a constant ratio. So we are halfway to developing a general formula for this geometric sequence. Right, I want you to consider the fact that we are multiplying by 2 over and over again. Now, if we were to take this term 1, number 3, and multiply it by 2 a given number of times, we could get any term number in the sequence, all the way up to term 100, all the way up to Tn. So let's just think, how did we get from term 1 to term 4? Forget about the 6 and the 12 and the 24 for now. Have a look at these multiplying by 2's. If you started with 3 and you multiplied by 2 3 times in a row, do you agree we would get 3 times 2 times 2 times 2? Of course, it would end up with 24. So term 4 is 3 multiplied by 2 3 times. What if I asked you for term 5? We would do the exact same, except we'd have to multiply by 2 once more. So our 5th term would be our first term, term 3, multiplied by 2 4 times in a row. I hope you're beginning to see a link here. Term 4 was the first term multiplied by the constant ratio 3 times, difference between 4 and 3. Term 5 is the first term multiplied by our constant ratio 4 times. There's a link between 5 and 4. And once more, just for some consolidation and reinforcement, if we had to get term 6, do you agree that we'd have to go times 2 times 2 times 2? Once more to get term 5, once more to get term 6. So we would have to take our first term, number 3, and multiply it by 2 5 times in a row. I'm quite sure if you are confident, go replace the 4, 5, and 6 with n. Replace your 3, 4, and 5 with n minus a certain number. Replace 2 with the number r, with the letter r for constant ratio. And replace 3 with A, and A can represent your first term. See if you can write down the general formula. I'm giving you 3 seconds. Pause quick. I'll be so proud of you if you do this. Okay, I hope you did it. If you didn't, cease. So this is the general formula that we can generate from having a look at basically multiplying terms over and over again by the same factor. And this is on your formula sheet. And this right here, ladies and gentlemen, is called the geometric sequences general formula. A is just another way of saying term number 1. R, you can see over here, I've given it on the right, is called the constant ratio. And N, just like in the quadratic and the linear number patterns, N represents your term number. So there we have a general formula. Let's jump into an example where we can apply this formula and extend our minds. Okay, so easy peasy example. We just need to determine the general term for this given sequence. 1, 0, 2, 0, 0,04. Now, this is obviously a geometric sequence since that's the topic of the lesson. But if it was just asked to you and you didn't know which kind of sequence you were dealing with, then go through the process of checking for a constant difference, checking for a second constant difference, and then checking for a constant ratio. Just remember to double check all 3 of those, and for this one you'll see that we do have a constant ratio. If you take your second term 0, 2 and divide it by 1, your calculator is going to help you, or you can just use your own brain to realize it's just going to give you 0, 2, or if you are like me and somehow prefer working with common fractions as opposed to decimals, you can write 1/5. If you left it as 0, 2, that would be perfectly fine. Then let's just double check that term 3 divided by term 2 gives us the same answer. Yes, it does. Whoop, whoop. We have a ratio of 1/5 or 0, 2. So let's write out our formula and sub in our relevant values. A is the first term, which is 1. And R is our constant ratio, which is 1/5. In general terms, we always need N and Tn to be part of our final answer. So we have done what we need to do. That is that. All I'm going to do is neaten it up. 1 multiplied by anything is just the same number. So I've dropped the 1 times, and I've got my final answer as Tn is 1/5 to the power of n minus 1. One thing I'd like you to realize is that geometric terms or geometric formulae, geometric sequences are merely exponential graphs. If you were to sketch this thing, it would be an exponential graph coming down from high up, down low to the ground. It's a decreasing exponential graph. Why is it decreasing? Tell me something about its base. The base of the exponent is a fraction, and so I'm going to show you the shape of this graph with my laser across the screen. It would come down, slide down, and it would approach an asymptote. What would that asymptote be? Just the x-axis, because we haven't slapped on a constant to the end of this formula. Okay, also remember, we can ask you what is the value of the 9th term. Then you go and pop a little 9 in the place of n, and you get the value of a certain term number. What if I asked you which term number has a value of, say, 1 over 15? Then you go and replace this Tn. You replace the left-hand side of the equation with 1 over 15, and you try and solve for n. Now that's what we're going to do in the next example. So which term of this sequence, 2, 6, 18, is equal to 4,374? I'm sure by now you're picking up on the geometric sequence constant ratio really quickly. We take our second term divided by the first term, and if you want to double check it, take your third term 18 divided by your second term 6, and you'll see, okay, our constant ratio is 3. What are we going to replace a with? Our first term. So the general formula for this sequence is Tn equals 2. We got it from there. Times 3 constant ratio to the power of n minus 1. Now, I know it doesn't look like the most compact formula, but that is your final answer for the general term. Don't try and distribute this 2. Please remember that BODMAS means brackets, and then O stands for order of indices. So this n minus 1 has to be applied to the 3 before you can multiply. Do not make the fatal mistake of saying 2 times 3 gives you 6 to the power of n minus 1. If you do that, you will be in big trouble. Right, so here we're asking, which term? So we have been given the term value, and we're looking for n. So we set up an equation where we replace our Tn with 4,374, and now we somehow have to get this bad boy all by himself. Okay, let's undo the multiplication. 4,374 is equal to 2 times something. How do we undo timesing? We divide. So we divide both sides by the 2, and we get 2,187 is equal to 3 to the power of n minus 1. Now this 2,187 is just 3 to the power of 7. How did I know that? Because whenever you are solving for exponential equations, please remember that you need to get numbers as a product of their prime factors. What am I talking about? I'm talking about that amazing function on your calculator where you can convert 2,187, press equals, press shift, press fact, the button that has fact. It's the button with all the commas on it. Then your calculator will help you convert this big number into a product of its primes. Now that our bases are the same, we can drop them, and voila, voila, n is 8. Okay, so last example for the day. Don't be alarmed by the variable x. We know everything we need to know in order to tackle questions like these, and I can guarantee they will creep up on you. So if x minus 4, x plus 2, and 3x plus 1 are the first 3 terms of a geometric sequence, determine the sequence if x is positive. So it's all here in the question, and I warn you, you're going to move on, and later on in the year when you do revision, a question like this is going to creep up, and you're going to disregard the fact that they have told you this is a geometric sequence, right? The minute you see the word geometric sequence, you need to think constant ratio, constant ratio, constant ratio. What does that mean? It means R, which is the second term divided by the first term, So x plus 2 divided by x minus 4, that will be exactly the same. T2 divided by T1 will most definitely 100% guaranteed be equal to the third term divided by the second term, because they have told us that this sequence is geometric. So I already know my ratio can also be written as my term 3 divided by term 2, which is 3x plus 1 over x plus 2. So here we have it, ladies and gents. This fraction over here is in fact equal to this fraction over here. So let us solve for x. What's the easiest way to solve when you have a fraction equal to a fraction? Let's cross multiply. In other words, we're finding an LCD and we're dropping the denominator in one quick, swift step. 3x plus 1 times x minus 4 is going to be equal to this numerator x plus 2 times that denominator x plus 2. Now don't be a lazy bugger. Pause this video, FOIL out those brackets and solve for x. I'm not showing the steps on how to get to x. I'm just showing you the answer. Please quickly double check if you can do it yourself. Warm up your brain. Don't just sit here mindlessly watching these videos. I want you to interact and be proactive about your learning process. Right, so let's see. Blah, blah, blah. Pause now. And I hope you got the same as me, that x equals negative a half or x equals 8. Now remember, the question said determine the sequence if x is positive, so we can ignore the negative a half solution and we can just work with 8. Now you may be wondering, what the heck do they actually mean when they say determine the sequence? It means generate term number 1, term number 2, and term number 3 using the value you found for x. So I'm not showing the substitution because I know you know that when you put 8 in the place of x over here, 8 minus 4 will give you 4, 8 plus 2 will give you 10, and 8 times 3 plus 1 will give you 25. So the sequence is 4, 10, 25. There you've answered the question. However, they could ask you to find the general term, and then we go and find the actual value of our constant ratio, which will be 10 over 4, 5 over 2. So that's 2.5. And then you substitute it into our general formula. I know you've got this, and voila, we are at the end of geometric sequences. I hope you're ready to move on to series on Monday. I can't